Hey, hi everyone, this is Phil from statisticsmentor.com. Now, when I asked you the question, what does it mean to say that two events are mutually exclusive? And what does it mean to say two events are independent? You probably have definitions in your head, but have you got them the right way round? Well, more often than not, I find students get them the wrong way round. And thinking about it, I think that if you think about what the words mean, then that will help in not getting them the wrong way around. Let's look at mutual exclusive first in context of two events, non-trivial events A and B. Now, I find some students don't realize that we can picture this as a Venn diagram, and if you do it, it makes life a lot easier. So two events being mutually exclusive, so this is event A, this event denotes event B in the sample space S. As the word suggests, mutual exclusive, right? What's exclusive? So say that event A happens, that's exclusive. In the words of exclusive, it means that only certain members are allowed. So if it's exclusive to A, B can't happen. So in this case, this Venn diagram here depicts a picture where A and B are mutually exclusive. If A happens, B can't happen. In other words, in the Venn diagram, A and B do not overlap. Or I could say, if B happens, if the event, then A can't happen. So think about mutual exclusive as being selfish. It's all about me. So if one thing happens, the other thing can't happen. In terms of sets here, we could write it like this. To say two events are mutually exclusive, we're saying that the intersection, i.e. where they overlap, these two sets, is empty. Recall that we do not write 0. 0 is a member. We write this to say it denotes an empty set. Okay, so not 0, because 0 is actually something. Or we could write, in terms of probability of A and B, it doesn't happen. So 0 chance of happening. Alright, either of these matches up with this picture of mutual exclusivity. And then that leaves independence, and independence must be the other one, which means that if A and B are independent, outcome of the one does not affect the chances of the other one, outcome of the other one occurring. The way we can write this is that if A and B are independent, given that B has occurred, does that affect the probability of A? No, so this is probability of A. Or we could say that probability of A and B, this is a bit more technical, this one, is equal to probability of A times probability of B. This is for independence. Right, so let's look at some examples, and sorry for the atrocious handwriting. Let A denote a head on one throw of a coin. Let B denote outcome of the value 1 on the throw of a die. Now, events A and B, if you think about it, are they independent? Yes, because the outcome of a throw of a coin does not depend on the throw of a die. Are they independent? I mean, are they mutually exclusive? Can you get, does probability of can A and B happen? Yes, you can get a head on one throw of a coin, and you could get a 1 on the throw of a die. Next, Team GB wins 100 gold medals at the next Olympic Games. And second event is I pass my stats exam. Are these two things independent? The answer is yes. This outcome does not affect that outcome. Vice versa. Are they mutually exclusive? No, because they could both happen. Next, A is the outcome of a throw of a dice is odd number, B is the outcome of the throw of a dice is an even number. Okay, now are they mutually exclusive? Yes, because if one happens, the other one for sure can't happen. It's got to be even or odd. Are they independent? No, they're not independent, because if you know that one of them is odd, for certain it can't be even. Finally, two events. A is I pass my stats exam, B is I fail my stats exam. You can see you can't have both of them happening, so they're mutually exclusive. Are they independent? No. At the introductory level, we need to be able to distinguish between independence and mutual exclusivity, and in this video we've done that for two events. Okay, I'll leave you with a fact that I'm going to just give you without proof. Is there a relationship between dependence and mutual exclusivity? Well, if you look at the previous examples, there seems to be a pattern, and it's as follows. Two non-trivial events. So let's just non-trivial means that probability can't be 0, otherwise it's not very interesting. So let's just say probability A and probability B bigger than 0. Then the following. Events can't be both independent mutually exclusive. Events can't be both mutually exclusive and independent. Second thing. If A and B are independent, another way to write that if you're interested is this, like this. So, if A and B are independent, this implies A and B are not mutually exclusive, and if A and B are mutually exclusive, it implies they're not independent. In other words, in short, if it's one, it can't be the other one. An interesting result that many students miss out on in their first look at these concepts of independence and mutual exclusivity. If you're interested in the proofs, they're quite short, and look out for that on the next videos. Okay, hope that's been helpful.